Well, good morning, everyone. Hi, my name is Jenny Whitener. I'm with Bridge Innovate, and I'm excited to welcome you today to a very inspirational session, Biomimicry, How Nature Inspires Innovation. As we get started today, I'd like to invite our guests to go into the chat and introduce yourselves. It'd be nice to know your name, your organization, and just as we hear from our guest speaker today, continue the conversation, right? Share your insights, maybe pose a few questions. Hopefully at the end, if we have enough time, we'll actually be taking questions from you as an audience. So again, welcome to Biomimicry, How Nature Inspires Innovation. And please do go into the chat and say hello. I can see John saying hello, others joining in as they're introducing themselves now in the chat. So thank you so much for that. Let's jump in and get started. Today's program is a part of the Inspire series offered by Bridge Innovate. It's part of our Innovation for Good offer, where we find amazing leaders around the country who are doing wonderful things in innovation, leadership, and change, and ask them to share their inspirational stories. And so it's very exciting for us today to have our special guest. On the next slide, I'm happy to introduce to you Andrew Meador. Andrew is an education professional. He's been in the industry for over 11 years. He's originally from the Indianapolis area, having transplanted himself and he and his wife to Chattanooga. He loves scuba diving, skateboarding, bird watching. You can see this giant mural of a bird behind him, and producing music. His resume includes a really interesting set of combinations from nanotechnology research to quality assurance, chemistry, and over 10 years in STEM education in the public, private, and charter school segment. So without further ado, I'm excited to introduce to you Andrew Meador, and then I'll let him take it away from here and tell us more about himself and his perspective on biomimicry.
All right, thanks, Jenny. Yeah, I'm going to start sharing my screen. So we're really excited to be here today and really grateful to Bridge Innovate, Jenny and Luke for having me. So my overview, I'm going to have three main portions to my talk. One is defining biomimicry. Second, I'm going to present a strong case for why biomimicry is so important to our future. And then three, I'm going to talk a little bit about how our future could be inspired with hope from biomimicry. So I like to engage imaginations with people. And I wanted to just ask, put in the chat, what's your favorite animal? So something lighthearted, something fun. What's your favorite animal? Just right off the top of your head. And I'm going to open the chat. Ooh, liger, manatee, wolf, honey badger, leatherback sea turtle, chickadee, cat, bear, tiger, giraffe. Cool. So my favorite animal is the osprey. It's a pretty common species, especially around waterways like we have in Chattanooga. And the osprey is unique because it's its own section of the hawk family. It's specially adapted to fishing. It's very successful as a fisher. And in fact, one of its adaptations is that it can go from a foot arrangement that's called anisodactyl, which is typically in birds, they have 3 toes forward and then 1 back. From that to zygodactyl, which is 2 forward and 2 back, and it can switch between those two. And you can see the image on the left, the osprey carrying a fish. So it can switch its feet arrangement to streamline when it's carrying its load back to a nest. And that's important because it's such a successful hunter and fisher. Other birds just wait for the osprey to catch a fish, and then they try and attack it and take it, what it's just caught. You can also see in the middle picture, it has this unique wing joint that kind of makes a W. And when it comes out of the water, that allows it to take off just standing still, stationary, which is very unique in the animal kingdom for birds. And then it has other adaptations, like it can close its nostrils. It has an additional eyelid that acts like goggles when it goes underwater. And when I'm kayaking, I love to watch them soar around. And if you're lucky, you get to see them catch a fish. So let's move into the bulk of this. I want to give an overview and I want to hit all the key points. And so, like Ginny said, if there's questions, you can type them in the chat and hopefully we'll be able to address them after. So in general, biomimicry is applying nature's solutions to our problems. And the textbook definition of biomimicry is the conscious emulation of nature's genius. So I'm going to unpack this, but I also want to discuss what I consider to be the most important component of biomimicry, which are the three components. So there's an ethos component, which is kind of a spirit with which we approach this work. There's the reconnect component, which is asking us to rekindle our connection to the natural world. And then there's emulate, which is where the innovation and the design thinking comes in. So first, there's a little bit of delay when I'm hitting. All right, there we go. So the conscious emulation of nature's genius. One, conscious. What does that mean? It's intentional, it's studied, it's observant. And this highlights the reconnect element of biomimicry. So reconnect with in parentheses, because everyone has a different connection to nature. Some of us are living in the concrete jungle. Some of us are living in more rural settings. Some of us make time for nature. We each have a different connection to nature and to the natural world. So the reconnect element is simply asking us to rekindle that connection to nature, to go spend time in nature and observe what we see. So this image of a yellow garden spider, this is a ubiquitous species in the North American and Canadian, a little bit down in the Mexico area. And the spider is unique. It's called the riding spider, as you can see, because it weaves these special strands of web that reflect ultraviolet light. And that ultraviolet light is really important. Scientists have studied, and they think it's because these spiders are unique. They don't rebuild their web very much. And so the UV reflective threads keep birds from flying into their webs. So bird vision, they can see in the ultraviolet range, which we can't. And so these spiders are using that natural technology to help them. And then the emulation component, which is the design component, means to match or surpass, typically by imitation. And it's really you're acknowledging the utility of what we see in nature. This is the emulate component. And you can see an image here on the right. A German company called Ornilux was studying spiders, and they worked with a glass manufacturer to create this product. So what they did was they wove UV strands into their glass, and they found that that stopped bird collisions in skyscrapers and zoos and residential areas. So an innovation from a spider helped to make the built environment safer for the natural world. And then the third component, which is nature's genius. So nature has done years and years of research and development, and the result that we see today around us are a multitude of champion organisms that thrive in many incredible, unique environments. So we look at ecosystems, we can look at systems, we can look at individual organisms, and we can also just examine the form of something in nature. And this is really important because this ethos component, which is the last component, is asking us to approach nature with humility. Instead of looking at nature just as a warehouse of materials for us to use, it's asking us to consider that nature is a library of knowledge from which we can learn, we can glean, and we can grow. If you take a moment just to observe when you're outside, go out into nature away from urban centers, there's so much that's going on beneath the surface that we don't understand. And so there is a really strong scientific component to biomimicry, because you do need to have some understanding of the science, the biology, the chemistry, the physics that's going on. But in general, nature is able to accomplish wildly amazing feats in ambient conditions. If you're thinking about how barnacles attach to ships or shorelines, the adhesive that they create is much stronger than the adhesives that we use, which are using toxic chemicals, very high temperatures and pressures. Nature is able to do that in ambient conditions, and it's able to do it without hurting the life around it. And so this is really the ethos component. It's that shift in looking at nature from, oh, this is something that I can just consume and use, to approaching it with humility and saying, what can I learn from nature? So some quick examples of biomimicry. We talked about the Ornilux bird glass. The Shinkansen bullet train in Japan is another really famous example. When it was first created, the train would build up pressure waves when it would go through tunnels. And then when the tunnel ended, it would create sonic booms, which would rattle residential houses. In some cases, it would shatter glass. And that's a big problem. The point of the bullet train was to go really fast, and it was having all of these residual side effects. So the lead engineer on the project was a bird watcher, and he noticed how a kingfisher, which is the organism that's shown here, it's able to fly into water and create almost no splash whatsoever. And so they studied the kingfisher beak. How do the fluid dynamics of the beak moving through the air work? And they were able to model the front of the train after the kingfisher's beak. They also used inspiration from a penguin and an owl for other parts of the train. And the result was eliminating the sonic booms and the pressure waves. There's 30% less air resistance, which meant that there was 13% less energy consumption, and it made travel times quicker. So on a short trip, they might not be significant, but on a 2.5 hour trip, that becomes a very significant difference in time. So that's an example of a physical and almost literal application of biomimicry. But there's also metaphorical applications, and these can be a little less clear, a little more esoteric. But here's one quick example, which is the burrowing tarantula and the dotted humming frog. So these organisms exhibit a mutualistic relationship where the tarantula protects the brood of the frog, and the frog eats bugs that would eat the tarantula's eggs. And so typically where you might see a tarantula eating a frog as a meal, these two have a symbiotic relationship. And so one metaphorical example that you could take away from a relationship like this in nature is cooperation instead of competition. So how could a business work with other organizations instead of competing with them, so they can bolster a relationship and they can thrive in their ecosystem? So next, the second portion is the case for biomimicry. And I love what Jenny is doing with Bridge Innovate. I've been a part of several of the design thinking workshops that they've done. And biomimicry has captured my imagination because it's captivating and it's an innovative design thinking approach. Not only do I get to think about the user experience and how is this going to interface into an existing system, but it also incorporates animals, nature, going outside and exploring, which is fundamental to our thriving as a species. So this summer, I noticed these giant grasshoppers started emerging in Chattanooga. And so I was curious, I did some research into them, and this is an obscure bird grasshopper that was chewing through the screens on our windows in the front of our house. And so I started thinking about, okay, well, there's already this window problem for birds and collisions. And so I did more research into that, trying to figure out, well, if there were more birds around, they would eat the grasshoppers, then I wouldn't have this screen problem. So we've got to replace several screens. We've lived in Chattanooga for 6 years, never had this problem. And so it turns out that warmer temperatures actually increase the brood size of these grasshoppers. So there's more grasshoppers, and for some reason, there's fewer birds. So this is an infostat from 2017. And this is talking about how there's a lot of talk politically and legislatively about wind turbines being harmful for birds. And while that's true, there are actually many more anthropogenic harms to birds than the wind turbines. So you can see there's poisons, there's collisions with vehicles, collisions with buildings account for almost 600 million deaths per year. But the biggest component of this are feral cats. So the domestication of cats getting out of control, and a staggering number every year, about 2.5 billion birds every year are killed because of feral cats. And so this got me thinking about how deep all of these ecological niches are working together. I started thinking about, okay, well, if we do this with the windows, then that'll increase birds, but then there's all these other factors. And so even though it is staggering to some degree to reckon with these numbers, I find it fun to find the challenge in design, to innovate, to try and work with the natural world and come to a conclusion. So biomimicry has the capacity to deliver us from bad design. And bad design is everywhere. It can go anywhere from inconvenience to infuriating to, on the other end of the spectrum, it can be deadly, not just for other organisms, but for humans as well. So what's an example of bad design that comes to mind? For me, it would be airplane seats. I absolutely hate flying on airplanes because I can't sleep. Like, my body just can't get restful sleep on an airplane. There's minimal space. And when I'm on an airplane, since I can't sleep, I inevitably end up wanting to get on my laptop, do some work, because it's a chunk of a couple hours when I can knock some things out. But every time, especially this year, anytime that I've flown somewhere, I'll put my tray table down, I'll put my laptop down, and the person in front of me violently reclines its chair back. And because of the design of these tray tables, it ends up folding and compressing my computer and shutting it very harshly. And it's so frustrating. I started thinking about, well, what if there was a way to communicate with the person in front of you so they could say, hey, I'm going to recline my seat. But instead, we're just forced to live with these designs that are anxiety inducing, they're inconvenient. And then at the other end of the spectrum, there are deadly cases. So if we're examining how can we reimagine the built environment, how can we make this better, not just for humans, but for the earth, for the natural systems, the organisms that we share this space with. This is an Australian design project called Meet Graham. And this team was challenged to create a human that could survive car crashes. And so you can see the head is enlarged. There are fluid-filled sacs on the chest. And you can just see how grotesquely reimagined we would have to be to survive in the environment that we've created with the designs that we're currently using. The second aspect of this is it's not just an isolated design thinking approach. It's holistic. It incorporates our psyche in addition to the knowledge and the practices that we're approaching a challenge with. So especially in psychological studies that are finding out that connection, community, being around others, and how important that is to factors like addiction, to mental health. This is really important for us to find that gratitude from nature, to go out, to connect not only with other humans, but to connect with the natural environment. A non-medical condition that's been rising in popularity has been nature deficient disorder. And it's this idea that as children, we're largely incubating them from their natural environment. And so we've seen the rise of forest preschools and many other projects and goals that are trying to get kids out of the classroom, out of a room, and into the natural world. And I think it brings up a really important question for each of us, which is, are we out of touch? As much as 50% of North American residents can go an entire week without touching a natural surface. So that means they can walk on their floor in their house, go out to their concrete driveway, drive on a road, go into another building without even so much as interacting with a natural surface. And it's led to many interesting phenomenons. One is nature as tourism. So just like you would go and plan a week in Disney World, we go and plan our weeks in nature. It's a vacation. It's an escape. It's an escape from the world that we have built and created. And then we have nature as entertainment, which is the double-edged sword of having social media, having access to rare exotic organisms, out of touch places that are very difficult and challenging to reach. And it's all in front of us. And many times we can fool ourselves into thinking that we're interacting with nature through a screen, through a mediator. And then the question, what does our use of nature reveal about our value of nature? Again, in the ethos component, going from how can I use nature to what can I learn from nature? It's a really important ideological shift. And so the final component of this case for biomimicry is framework for environmental accountability and regeneration. So biomimicry provides a way for us to measure how life-friendly our designs are. And this is accomplished largely through life's principles. So I work with the Biomimicry Institute, which is a nonprofit that's focused on educating and spreading biomimicry. This is from our for-profit side, which is called Biomimicry 3.8. And they developed these principles that they observed in nature, in organisms. So for example, in this top one here, adapt to changing conditions. One way that you can measure the success of your design from a sustainability or a regeneration standpoint is, does it embody resilience through variation, redundancy, and decentralization? So one quick example would be looking at a forest. A forest has many trees, many different organisms. There's many layers to the forest. And so forests embody resilience through the variation of the different species, lots of trees, lots of different insects, lots of different animals. But it's redundant in the sense that trees all kind of occupy the same niche, right? The roots stabilize the soil. They provide shade and shelter for animals. And it also decentralizes any one species from bearing the weight of the success of that ecosystem. So this final portion of my talk is our regenerative future. And even with all of the examples of poor design, bad design that we see, even with all of the harm that is caused by our designs and the current infrastructure of the built environment, there is still plenty of hope. And there's lots of hope, not necessarily because of how great we are, but there's hope because we are becoming aware of this problem. More and more people are waking up to seeing, oh, I'm not connected to nature. Oh, this is causing me to respond in this way. Wow, I don't really value what the natural world has to teach me. And so an example of a product that is doing really great things is e-concrete. And e-concrete is on the West Coast. They've included a lot of coastline concrete replacement. So over 50% of the world's population lives along coastlines. And most of that is using sterile concrete, traditional concrete, which has a huge carbon footprint from the production process. And it doesn't integrate with nature. It actually is toxic and poisonous to nature. So e-concrete came along. They did some studies that looked at different organisms, and they wanted to create a concrete substitute that didn't sacrifice in the quality of the product, the strength, durability, but that was a natural thriving point for organisms. And so e-concrete has several different products. They've reduced CO2 emissions by incorporating byproducts and recycled materials, and it enhances natural processes and it restores natural biodiversity. And as these organisms gather and group on e-concrete, natural biocalcification processes actually strengthen the concrete and it gets better over time. And so this is a quote from Janine Benyus, who coined the term biomimicry. And it's a sustainable world already exists. So many people are reaching and grasping to try and find ways to make the built environment more life-friendly, more green. But we have a perfect model. We have a perfect mentor in nature. It's showing us how to create a sustainable world that interfaces successfully with itself. And so that's my talk. And if you would like more information, you can email me at learnbiomimicry@gmail.com. Thank you.
Thank you, Andrew. How amazing and how inspirational. And I was just going to remind our audience today that you do a lot of work with adults, not just, with students. And so please do reach out to Andrew. How exciting to hear your stories and the impact of studying biomimicry and what that can do for us on the design side. I'd just like to ask our audience today, if you have any questions, you want to pose those in the chat. We've got a couple minutes and I'll see if some things are coming in. I've got one from John who's saying, have you studied swarm tactics and other concepts studied by the US military? Any thoughts there?
Yeah, there is some work. The swarm mentality, like especially with bees or colony insects, has been deeply studied, not necessarily so much by me. Personally, because I love scuba diving so much, I try and focus on the aquatic environment. But there's a really interesting design that works with integrating air conditioning units to a cloud-based system so that in a building, not all of the air conditioning units are running at the same time. And so the air conditioning units autonomously and using artificial intelligence turn on and off based on usage, based on voltages. That's a really interesting application. I think it's called Regen Energy. Mm-hmm. And other than that, there are many metaphorical applications to that.
Right. Very, very interesting. I can see there's just an automatic connection of inspiration when you think about something in nature and how you would apply that. It reminds me of a student design competition that Bridge helped to sponsor at Cooper Union in New York several years ago in partnership with the Royal Society of the Arts. And we had a group of college level students competing on sustainable design. And one particular student group from Savannah College of Art and Design came forward with an eco-friendly parking lot that became an aviary and water filtration system. They found in Detroit parking structures that were right near the river. They redesigned those parking structures to be water filtration system as water came down from when it would rain, and it filter through the parking deck and then go into the river more clean than where it came out of the sky. And then they put plants all around the parking deck exterior to attract birds and butterflies and all kinds of plant life, and to also cool the environment with all the concrete in the arena. So many ways that we can use biomimicry and the power of nature to inspire designs. Thank you so much. Andrew, for your inspirational talk today. We have more coming up at Bridge Innovate. There is a session we're going to actually have later this week on September the 16th. We have a student design challenge called the Future of Home for 4th grade through 12th grade. It's part of our Give Back, where every year we run free competitions for students. And we have a Q&A session. So if you know of a teacher, a parent that does homeschooling, or even a student that wants to pop in, we're going to be doing a Q&A session on that upcoming design competition and invention challenge on the Future of Home on the 16th. And then all other kinds of fun things going on, from the Foresight Scouts program, a briefing on that on the 17th. UTC, one of our major clients, the University of Tennessee, Chattanooga, talks about all the amazing things they're doing to ignite innovation across education and research, coming up on the 29th. And you don't want to miss Rob Evans. From Group Think to Group Genius. Join us October 6th. Rob, good friend of mine. He ran all the accelerated solution environments for Ernst & Young worldwide, was the leading partner on that. And I've convinced my good friend to come back and share his story with us on the 6th. So we hope to see you again on more programs on our Inspire series. And I hope you have a wonderful rest of the week. Bye, everyone. See you soon.